All right, so we're about to start. I see people are coming in. All right, I think we can start now. Hello, everyone. My name is Alper Yegin. I am the CEO of LoRa Alliance. Welcome to the very first AMA Ask Me Anything session of the LoRa Alliance. Just to do a brief intro about myself, I've been involved in the LoRa Alliance since 2016, a year after the LoRa Alliance was formed. I have chaired the technical committee for about 8 years before I took over the CEO role back in October 2024. And ever since then, I have been the CEO of LoRa Alliance. Um, so in this session, I'm here to answer your questions. So you can drop in your questions in the Q&A box and I will be answering them. Now, I don't see any questions yet. I wonder if the Q&A is active. So, Chansey, if you can check if the Q&A is, oh, there it is. Okay, the questions are coming in. All right, so again, this is an AMA. Obviously, anything involves the LoRaWAN technology and the LoRa Alliance. Feel free to ask any questions, whether it's technical, like how LoRaWAN works, what are the ongoing work items, how it's evolving, what are the use cases, success stories, also about LoRa Alliance, membership structure, how to get involved, what to get out of it. Very welcome to ask them. So let me see the first question now. All right, good. The first question is about certification. All right, so I'll just narrate the question. So there are several certifications for the IoT devices like FCC, CE, and CC. The question is, does LoRa also require certification? And also, does LoRa, meaning LoRaWAN, support full modular approval, which means the end product doesn't require approval as long as built with a certified module solution with certification? All right. So in addition to the local certifications one needs, the LoRa Alliance also provides a LoRaWAN certification for the end devices, not for the gateways, not for the network servers, but for the end devices. In order to use LoRaWAN, build products and deploy them, one does not need LoRa Alliance certification. It's not a mandate. Nevertheless, we strongly recommend having your own devices be certified and also be demanding the devices that you use be certified as well to ensure high quality, so you would have minimum headache and challenges when deploying these products. So again, it's not mandatory, but it is very strongly recommended the end devices be LoRa Alliance, LoRaWAN certified. And if you are using already a certified module, there's a certification by similarity program, which reduces the overhead of getting your device certified. So you don't get automatic certification, but the testing requirement is much lower. And there's the so-called CBS, certification by similarity program, that you can apply for and get your device certified, the device that happens to be using a certified module as in your question. All right. So let me go to the next one. Yeah, the second question is about the device lifecycle management. So the question is, in large-scale IoT infrastructures like more than 1,000 devices, what are the best practices for organizing the maintenance and lifecycle management of edge devices, better powered? Are there frameworks or tools you recommend to ensure operational efficiency and minimal field intervention over time? So in LoRa Alliance we have several protocols and features of LoRaWAN that we have built to make the device lifecycle management easier. Things like QR codes. QR codes go along with the end devices, and they embed the end device identifiers, and they are typically used for easy provisioning of end devices on the networking platforms. And also using separate standalone join server where the device credentials, the device ID, the EUI, and the app key are stored, which facilitates onboarding the end device on any network server that happens to be leveraging this standalone join server. So these are two of the protocol extensions we have with LoRaWAN, and we also are working on additional features for plug and play to streamline onboarding devices. And that's an ongoing work item under the plug and play task force under the TC, which, by the way, is open to any type of member in the LoRa Alliance. Whether you are an adapter level member, contributor, or sponsor, you can participate in these task forces. And in short, we have a couple more tools we will be putting out. But then, on top of the interoperability specs we provide, the rest will be or is being addressed by the network platforms, like the network server platforms, the application server platforms, for the full device lifecycle management. So we provide them whatever is needed for interoperability. But then I would say like at least 50 to maybe 80% of the full device lifecycle management is a matter of implementation, which you would expect the platform vendors to address, and which they are addressing. But obviously, there's a lot of room for improving the full plug and play aspect of managing these devices. So. Okay, let me jump around because a few questions came from the same person. I'll jump back to them. All right, that's a good one. So the question is, we're using an LTE connection for LoRaWAN gateway. We want to optimize our LoRaWAN network in terms of data usage. Currently, the very popular, to my understanding, implementation of LoRaWAN gateway, Semtech Basic Station, is using JSON-based encoding for data transfer between gateway and LNS. Are there any plans to promote use of binary encoding in LoRaWAN gateway implementations? Very good question. Today, among all the interfaces we have in our network architecture, the gateway to network server interface, we do not have a standard yet, but we have an ongoing work on it. The NS Gateway Interface Task Force under the technical committee is working on that. And the very issue you brought up, the efficiency of the transport between the gateway and network server is already taken into account. Because like you say, there are gateways using cellular backhaul where the data cost is an issue. Or there are even cases where the gateways are using satellite backhaul. In either case, using a binary encoding for transporting data and control between these two endpoints is very essential. And this is exactly what we have taken into account in the upcoming NS Gateway interface design. So the answer is yes, the upcoming standard API is already supporting binary encoding. Question is, advantage of LoRa over Wi-Fi Hello. So Wi-Fi Hello is a new standard from the Wi-Fi ecosystem. It's very new, right? It is only supported by a few semiconductor companies, not the largest ones, but the other challengers mostly. And its range is definitely higher than Wi-Fi, but it is much less than what we provide with LoRaWAN. So with LoRaWAN, we're looking at, in case of line of sight, 500 to 600 kilometers. By line of sight, we mean when you put a base station on a low Earth orbiting satellite. This is the kind of range we're able to get out of LoRaWAN. We have two satellite providers, satellite operators providing commercial service with LoRaWAN via LEO satellites. Those are Lacuna and Plan S. We even have EchoStar Mobile providing a geo-based satellite connectivity, pan-European commercial service. Now, these geo satellites are more than 35,000 kilometers away from Earth. For that, one cannot really use the unlicensed band and the transmission power limits like 25 milliwatt. And for that, EchoStar Mobile is using S-band with 100 milliwatt transmission power. And the kind of range is, as I just said, more than $30,000, which is huge. Wi-Fi Hello is much less than that, I think in the order of like few kilometers. And the power consumption is not as low as what LoRaWAN has. And the reason behind that is LoRaWAN is built from ground up from day one, specifically for long range and low power. That's why we're able to provide such a long range while consuming so little power, because the whole system is built for that, as opposed to something like Wi-Fi Hello or take Narban IoT. These are relatively, I mean, these are retrofitted versions of what was originally designed for broadband access, for real-time communication, for pushing megabytes and gigabytes of data, right? For that reason, all this lightening up done by these other organizations, they are not a match for what LoRaWAN provides. So let's mark this done as well. All right, the next question is, what is the state of standardizing downlinks? Not all vendors are equal. And in many cases, we have to go through advanced documentation just to be able to find how to remotely change the uplink period. Is there a plan to have standard configuration UI that can be implemented in all network servers? Thank you. Well, LoRaWAN supports both uplink and downlink, right? It provides bidirectional communication. Now, the downlinks, typically downlinks generated by the network server would be the downlink commands, right? Typically, transmitting a downlink frame with an application payload would be initiated by the application server. It is true there are cases where the application server is co-located with the network server, but in most typical cases, they would be separated. And when they are separated, it is the application server that pushes a downlink to the network server, and then the network server pushing that downlink to the end device. And if it's a Class A end device, the network server has to wait for the next uplink and then take RX1 and RX2 as an opportunity to push the downlink. If the end device is using Class B, the network server will keep an eye on the upcoming ping slots. And if the end device is Class C, the network server can push that pending downlink at any point in time. So this is how the network server really does the downlink pushing. Either it's a MEC command, the network server sends the MEC command on its own based on the algorithm it has implemented, or it's a downlink that is coming from the application server. Now, having said that, I know the network servers also have a way to manually push a downlink to the end devices. Some of them provide you a UI where you can type in the hexadecimal value and the port, and then say, please push that downlink payload to the end device. Now, this is using the standard downlink MAC framing, but the rest is just an implementation matter. And it's not something that we would be supporting because it's just a UI matter. It's a UI design on the network server, and we, on the LoRa Alliance side, it is not an interoperability element for us. Interoperability is like, how do you make sure a network server from one vendor or any vendor works with a an end device from any vendor at the LoRaWAN layer. So yes, there's really no plan on standardizing the UI that resides on the network servers. And what you get out of your network server depends on the network server vendor. Okay, I need to. All right, so next question is, what is the LoRa product? By the way, I mean, I see people are using term LoRa, but obviously our standard is LoRaWAN. And let me also dive into this terminology thing, which does give this discrepancy. Now, this name of the standard is LoRaWAN. LoRaWAN is the link layer that provides framing, security, data transport. And this link layer design is using different modulation techniques or the physical layers, one of which is LoRa, another one is LRF-HSS. Also, FSK is another modulation we support. So our standard is called LoRaWAN, but obviously we're using a language and, it's relatively easier. People say LoRa instead of LoRaWAN, but all of these questions are about LoRaWAN, and I'm answering them in the context of LoRaWAN. Sometimes when people say LoRa, most of the time they mean LoRaWAN, but they use this unfortunate shortcut. But sometimes they mean a proprietary stack over LoRa modulation. So instead of using LoRaWAN, the standard, they use a proprietary communication stack over LoRa, and they really mean they're using LoRa. They mean they're using a proprietary stack over LoRa. All right, so the question is, what is the LoRaWAN product do you think is the most useful for your clients? Well, LoRaWAN is serving all 7 verticals of the IoT landscape: smart cities, buildings, smart homes, smart industry, smart agriculture, utilities, tracking. Now, obviously, it has different level of traction among these. So like water metering is a leading use case. So is smart buildings, tracking, campus-wide tracking, very large momentum. Whereas smart home, it has, relative to the others, the least amount of momentum. And nowadays, the fastest growing market segment for us is smart buildings and facility management. Why? Because LoRaWAN, being able to provide long range, obviously you don't really need long range inside the buildings, but what gets you long range is the high sensitivity on the receiver side, which works very well when captivated inside the building, where signals have to go through building walls and ceilings and floors, and also metallic obstacles. So being able to put in few LoRaWAN gateways and then the signals going all around the building and even outside is what makes LoRaWAN extremely preferable for this market. And also being low power, such that the sensors can last several years on single charge. These are the strengths that we've been enjoying. And to give you really concrete evidence how much momentum we have on that front, today, LoRaWAN, just to give you a few success stories, one of our board member companies, MachineQ, a subsidiary of Comcast, they have deployed LoRaWAN in more than 10,000 Starbucks stores in North America. And the place they use that is for cold chain monitoring. The temperature sensors being used across the stores. And in a typical Starbucks stores, there are 12 places they have these temperature sensors. And those sensors have been read manually. And then they wanted to remotely read them. And they have experimented with various wireless communication technologies. Given that these temperature sensors are typically inside a metallic fridge, or in a closet. Other wireless communication technologies had a hard time getting the signals through, whereas for LoRaWAN, it's been pretty easy. That's why they have deployed it throughout so many stores. And there are also other brands like McDonald's, Shake Shack, Five Guys, etc., that deployed LoRaWAN as well. And then Verizon Wireless is another board member in the LoRa Alliance, and they have deployed LoRaWAN in State Farm, NBA Arena in Atlanta. That's where Atlanta Hawks is playing. The whole arena is covered by LoRaWAN for facility management as well. And AT&T is another good example that started deploying connected spaces service using exclusively LoRaWAN connectivity. And a couple more examples on that. The world's largest pest control company, Rentokil Initial, they are 100-year-old, and they are it's a multi-billion-dollar company. They have recently joined LoRa Alliance, and I got on an intro call with them, and I asked them what brought them over, and their answer was, where pests are hanging around, typically in a building, are places which is extremely hard to bring wireless coverage through other technologies. Only with LoRaWAN, they had the confidence to bring internet connectivity to every corner of the building. And as such, their choice was clear, and now they're working on adding LoRaWAN to their product. So yes, our hand is extremely strong compared to Bluetooth, which can hardly go through a single wall. Zigbee, Z-Wave with mesh. Mesh brings complexity, and it increases the cost, and also operating the mesh nodes with batteries is a challenge. And any other technology like cellular definitely has its own challenges for being available, for being able to penetrate deep indoor. So LoRaWAN, among all these wireless communication technologies, stand out as the choice of wireless communication technology as the buildings are moving from wired connectivity to the wireless. So yeah, sorry, this was a little bit of a long answer, but there's a lot happening, and today we have the pole position in the smart buildings and facility management with our LoRaWAN technology. All right, so another question is, what is chirp spread spectrum? Is LoRa full duplex? So chirp spread spectrum, CSS, is a modulation technique, which is also used in the radar technology. And LoRa is using CSS, and basically that's how digital data gets modulated into radio waves and transmitted over a long distance. And then on the other side, it gets demodulated back from radio waves into the digital data. That's how we can push ones and zeros over the air. Now, above that is the LoRaWAN, which describes how we frame those bits and what kind of meanings we put on those bits so we can deliver data securely, reliably, and implement features like relay, photo, etc. Now, is LoRa full duplex? The modulation is just transmission, right? It really goes whichever direction you're aiming it. So and LoRaWAN is, yes, it is. It works in full duplex based on the base stations you have. You can run full duplex or simplex as well. And it is bidirectional. You can send uplinks from end device towards the network, and the network can send downlinks towards the end device as well. And this bidirectionality is needed for not only running sensors, but also actuators, which can be remotely controlled for configuration or for making this device do things like locking a door or unlocking a door. And also for features like firmware update over the air, we rely on the bidirectional communication. All right, so what marketing efforts by the Alliance are in motion to educate water, electric, gas utilities to the benefits of LoRaWAN for AMI? So within the LoRa Alliance, under the marketing committee, we have a Smart Water and Energies Task Force. That's where we have the critical mass of members coming together to exchange their insights, opportunities, and challenges in this vertical domain. On top of that, the marketing activities around smart metering is organized by that task force, and they are super active. They have been going all around the world and also doing webinars. So nowadays, we are in the midst of doing two webinars. Actually, we did deliver one about DLMS over LoRaWAN. So DLMS is one of the well-established communication stacks used in the metering industry. And we have adapted LoRaWAN to carry DLMS payloads. So the DLMS-based infrastructures can easily adopt LoRaWAN as a better wireless communication technology without having to change the rest of their stack. So there was already a webinar on that. This webinar was delivered by the members who presented the technology, who presented their offering and the use cases. And then the next webinar in that series is OMS over LoRaWAN, which is another well-established standard and stack. Same story. We support OMS over LoRaWAN as well, and we talk about that. So those are two educational pieces. On top of that, this task force organized members to be present at various events. So a month ago, they were in India at the ISUW event to present LoRaWAN to the Indian ecosystem. And another event they will be doing the same is at NNET, where they will be exhibiting several success stories to educate the market about the use and adoption of LoRaWAN. So we have several such activities. And the way to engage in such activities is to join the LoRa Alliance and then join these task forces. Introduce yourself, your company, your organization, and activities, and also start chiming in on all these discussions, whether it's about discussing what opportunities are there or how we should be steering the technology, because a lot of times those vertical groups, upon discussions, they come in and tell the technical committee what they need, and the technical committee, in response to this market demand, evolve the standard. A good example of that is the relay feature, which was developed in response to the demand coming from the utilities to provide coverage in the extremely challenging areas without having to deploy microcell gateways or without having to put in picocells indoor. All right, okay, let's see. I'm jumping around. All right, so, okay, that's a good question. Is there a plan to use NFC to onboarding LoRaWAN device in future LoRaWAN spec? That's a really good question. So for onboarding end devices on LoRaWAN networks, be it like the network server or application server, what we have standardized is the QR code. So we have a standard way of encoding the device ID, the joint server, and the vendor ID on the QR code. And that is one building block. By the way, we don't put, in case you're wondering, we do not put the app key, the shared secret key on the QR code, because none of such secret keys should be printed anywhere. Now, and having said that, we did have some conversation around how we could extend that to transmit the same data wirelessly. And NFC would certainly be a good technology for that. Now, that work, we had a verbal conversation on that, and then we said that this could be a future item, evolution of this QR spec, but we did not work on that. We haven't started working on that yet. I'm going to note this question. I'll bring it with the TC and ask them to see if they can accelerate this work. And obviously, things get accelerated if we have the members coming in and then raising this need within the TC or towards the TC. So if you are not a member, definitely becoming a member and pushing for that would help us accelerate. Our work is driven by the members. So anytime we see a need, we do discuss it, but then we listen to our members to help them to get them help us prioritize the work items. Because at any point in time, we have numerous work items that we can work on. We have to select a subset, and within that subset, we have to prioritize how we allocate our time within our committees, within our board, within our marketing activities, etc. All right, so question is as follows. From all the LoRaWAN use cases you have seen across industries, can you give an estimate of what percentage are periodic in nature? For example, applications where end devices send data at regular, predictable intervals. I'm considering developing a product optimized specifically for periodic environments, and I would love to understand how much of the overall LoRaWAN ecosystem that would potentially cover. It's really hard to say. These are very application specific. There are use cases where the end device transmits periodically. For example, one of the solar power temperature sensors, they transmit or it transmits the temperature reading every 8 hours periodically. Now, whereas say if we're looking at a vibration sensor, the ones that run the machine learning on board, to detect anomalies in the vibration, they send uplinks whenever they detect anomaly, right? Which is a very asynchronous event. Or say if you are running a meeting room occupancy sensor, which detects presence of people in a meeting room, it's not gonna transmit uplinks periodically. I would say majority of the transmission would be hard to categorize as a periodic uplink. Even those that happen to have periodic uplinks would have non-regular uplinks as well. Like if they need to detect, if they need to convey the battery issue, right, or the battery status, they would send such signals asynchronously. So yes, it is hard to quantify it, but I would say majority would not fit into a perfect periodic transmission schedule. All right. Is there an ongoing work to optimize LoRaWAN for FODA updates, and how does it balance energy constraints with the need for secure updates? So we already have a firmware update over the air feature with LoRaWAN, and it is already pretty much optimized. So how did we optimize it? So in order to send a large file, large for us, right? Like in the order of like 40, 50 kilobytes. That's typically what a firmware update looks like. It may not be the full firmware. It would be like a delta, the part that is changing. And when the network needs to push this much data, what we do is we bring a fleet of end devices, the collection of end devices that needs to be updated, to either class B or class C, because we cannot really push a large file like that, which will be chopping into fragments. And we don't want to be pushing every fragment one at a time to every end device. Instead, we'd like to bring all these devices to the listening mode, and then would like to push every frame once so they can all receive that. And that's an optimized way of using the downlink capacity, because we're not sending the same data like 100 times or 1,000 times. We're sending it only once. And in order to bring these devices to listening mode, we either use class B or class C. Class B is already a power efficient way of getting devices to listen on regular intervals. Class C is an always on mode, but in either case, we do that for a finite period of time, meaning that they don't stay in Class B and Class C forever. They only stay in that during this campaign. And once the fragments of the firmware is pushed, the campaign concludes. And then the network, the FOTA server gets updates on if any one of these devices could not get all the fragments, they report the state, and then the network transmits the missing frames. And we also do forward error correction in the firmware file, such that when we're transmitting, in case some frames are lost by some of the devices, up to a certain level of loss, the end device can recover the loss because we have redundancy in each fragment. Without the end device having to request those missed frames, they can reconstruct the missed frames by using the redundancy that's embedded in the other frames they have received. So these are all the optimizations we have in the FOTA. Obviously, in theory, there could be more optimizations, and we're always open for ideas that we can discuss in the FOTA working group. All right, checking more questions. Let's see. Oh, okay. How has LoRaWAN's relay helped? So LoRaWAN relay is actually a mobile. It's a LoRaWAN gateway. It's a base station. But what is special about it? Two things. One, it is better operated, meaning that you don't need to supply power to it. Two, its backhaul is not Ethernet, it's not fiber, it's not cellular, it is LoRaWAN itself. So it collects the uplinks from LoRaWAN end devices, and then it forwards them as a LoRaWAN frame to the LoRaWAN gateway. So that's what it does. As such, it has very high autonomy. There are no wires, and no wires for the power, and no wire for the backhaul. As such, it's a very low-cost way of extending the coverage. Now, the downside is its capacity is limited. You cannot really scale it to support thousands of end devices. Oh, one other thing is it's also very low cost. The LoRaWAN relay is designed in a way not to use a concentrator chip, which is used in the base stations, that supports multiple channels to be demodulated simultaneously. Instead, it's using the client chip, which is very low cost. But for that, it cannot listen on the 8 channels or 16 channels at the same time. It can listen on the Wacom radio channels, 2 channels, and then based on that, it just jumps on another channel to receive the uplink frame upon being woken up. So its scalability is limited. It supports like 10 plus devices, but it does solve an important challenge for the utilities where a deep indoor end device, like a 0.05% of the devices that happen to fall outside the coverage of a macrocell, they can easily be brought into the coverage by deploying these relays. Another advanced feature we're building is walk-by drive-by reading, which is basically a mobile gateway, which is like one step further. Imagine you have a house that's like in the countryside where you would not put a base station, you would not even put a relay there, and you're okay to read it like once a month, right? So having a mobile base station visit the neighborhood, maybe on the garbage truck or on another vehicle, that's walk by drive by reading. Today, one can already build such solutions with LoRaWAN. Now, what we're working on is to make it super efficient such that the end devices would not have to transmit uplinks blindly on a regular basis. They will wait until they detect the presence of LoRaWAN gateway, a mobile walk by drive by gateway. And that'll happen by the gateway transmitting beacons to wake the end device. so end device can transmit the uplink on a timely basis. So that is work in progress under the Network Discovery Task Force in Technical Committee. All right, so let me also switch to some of the questions that were asked in advance prior to the live event. So I'll be like alternating because there are really a lot more questions that I'm going through right now. I'm trying to keep up. Oh, okay, the nature lovers. All right, so here's the question. So would you explain clearly how does those systems, the LoRaWAN systems, work for regular people's user experiences? For example, if regular people, they are more like nature lovers than scientists. All right, so if you want to use LoRaWAN for the planet, right? So that's one of the strengths of LoRaWAN. It's not only serving the needs of businesses, but also needs of people and planet as well. On the planet front, there are solutions in the market like forest fire detection solutions. One of our members, Dryad, they build sensors that gets deployed in forests to detect smoke, smoldering, to detect fire even before it becomes visibly noticeable. Because at that time, it gets little late for a reaction. It requires a bigger reaction. But if we can detect the forest fire in advance, then it's easier to extinguish it. And that's what Dryad has built its solution for forest fire detection. And we also have LoRaWAN deployed in wildlife parks in Africa for tracking lions, endangered animals like rhinos, certain species of rhinos, lions, giraffes, and elephants. Also used for tracking rangers and even their guard dogs against poachers. The Connected Conservation Foundation is another new member of the LoRa Alliance who have deployed LoRaWAN in, I believe, more than 5 national parks in Africa. And nowadays, they're even working on integrating adjacent parks through roaming, such that when an elephant happens to roam, literally roam from one park to the other, the elephant can stay connected because 2 parks, having deployed 2 distinct network servers, would be interconnected through roaming, so they will still keep the tracker on the elephant connected. All right, so jumping around again. Question is, how do I check that the battery of my device is running out of power? Well, it's something you need to deal with on your device platform. It's really very platform specific how you can find that out. What we provide is there's a LoRaWAN MEC command for the end device to report its device battery level. That's how you would see on the network servers, they're able to track the battery level of the end devices by leveraging this LoRaWAN MEC command. Does LoRaWAN work with 5G ecosystem? Now, 5G, well, 5G can mean different things to different people, but the most official description is coming from 3GPP. 3GPP defines a 5G system based on the 5G new radio and also 5G core network, which are very specific standards coming out of 3GPP. LoRaWAN is not part of that. Wi-Fi is not part of that. Bluetooth is not, NFC, so on and so forth. It's very GSM family specific term, but again, this is the strict meaning of 5G. Whereas, like if we go back 3-4 years ago, the way 5G has been described was anything and everything wireless under the sun, okay? And in that case, yes, we're part of it. But that was the marketing spin, which kind of didn't stick around. And right now, 5G is a very GSM specific system, which does coexist. There are networks that build 5G and LoRaWAN side by side. There are devices that happens to be using LoRaWAN and other cellular technologies side by side, like a multi-mode gas meter from Italgas. It uses both Narrowband IoT and LoRaWAN. It prefers to use LoRaWAN wherever it detects, it finds the network. If there's no LoRaWAN coverage where that gas meter is, then it falls back to using Narrowband IoT, which does consume more power. It's more costly network. That's why it's a fallback. It's plan B. There are also trackers in the market that supports both Narrowband IoT LTM and LoRaWAN as well. So there are multiple networks and platforms where these technologies are integrated, but officially, LoRaWAN is not part of the 5G standard that comes out of 3GPP and GSMA. Yeah, sorry. What are some of the most promising and evolving use cases for LoRaWAN that the Alliance is currently excited about, especially beyond traditional applications like metering and asset tracking? So I did already talk about the smart building and facility management. That has tremendous amount of momentum right now. The other one is street lighting. That has pretty good momentum as well. For example, our member Tata has nearly 400,000 street lights connected across India and Saudi Arabia. We see a lot of momentum on that front as well. Smart industry, yes, I was at the Hanover Mess 3 weeks ago. We had several members of LoRa Alliance and the LoRaWAN ecosystem exhibiting at the event, and also the large players like Bosch, Wika, Pepperl& Fuchs, ABB, Honeywell, exhibiting and talking about their LoRaWAN solutions for the smart industry. So the smart industry, apparently, majority of the sensors are wired, and wireless is a small part of that. But within that small and growing part, LoRaWAN is playing a key role for it being able to provide connectivity in the very highly challenged RF conditions. And just to give you a concrete example, LoRaWAN, there's a LoRaWAN deployment in the Europe's largest oil refinery in Rotterdam, operated by Shell. Okay, and they are using LoRaWAN to connect temperature sensors, to monitor the position of valves, to also have vibration sensors. And again, this is a highly metallic environment and also highly hazardous environment. And for that, they are using ATEX certified gateways and sensors. So this is a level of maturity we have. And they are not the only oil and gas company having deployed LoRaWAN. Also, Total Energies and also Chevron have deployed LoRaWAN as well. So yes, smart industry has pretty good momentum. Smart construction, we see numerous projects on that front as well for tracking personnel, tracking assets, tracking the running conditions of the machinery as well, and smart mining, which is very adjacent to smart construction. So those are the areas that we see very exciting momentum in the market. All right, good, interesting question. Can we use LoRaWAN as a communication module in emergency in India? How efficient will it be? That's definitely an area I see products emerging. Now, for emergency communication, for short messaging, yes, you can use LoRaWAN, but you cannot use LoRaWAN for transmitting audio or transmitting video, because that would be, since we're using an unlicensed band, due to regulations, there are limitations like duty cycle limitation, dwell time limitation, which limits the amount of data we can push through LoRaWAN at those bands. And that's why truly real-time communication and being able to transmit megabytes and gigabytes of data, those are we cannot support them with LoRaWAN. But if we're talking about pushing short messages, which come very handy and life-saving in case of emergencies, those can be done with LoRaWAN. In fact, there are communicator products in the market for emergency response teams to use LoRaWAN. There's even one company built such a communicator using satellite LoRaWAN communication. So using the EchoStar Mobile's Geo S-band satellite LoRaWAN connectivity, a company called Connected has built a device that pairs with your smartphone using Bluetooth, and it has a LoRaWAN over S-band modem to push that data, whatever data it receives from the mobile phone, through the geo satellite back to the ground. And a very good use case of that would be for emergency communication. So I expect to see more such solutions coming to the market and accelerating use of LoRaWAN for emergency communication case as well. Okay, this is a good question as well. What are the cost factors when considering deployment of LoRaWAN-based sensors? So multiple elements you need to take into account. One of them is the cost of the end device, the hardware, right? The hardware cost and the support cost for the end device. Secondly, you need to have connectivity. Either you build your own LoRaWAN network, and that's the beauty of LoRaWAN. Because we are using unlicensed band, you can choose to build your own network depending on your use case. If it is a campus-wide network, say you're making a connected office space or connected factory or connected, say, university campus, then you can easily build and operate your own network. But if we're talking about, say, tracking an asset across the nation, unless you're a public operator, it wouldn't be cost effective for you to put LoRaWAN gateways wherever your assets may be heading, right? And for that, you would need to rely on a public operator in your country. Say if you're in France, Switzerland, Netherlands, Finland, say you're in Vietnam, Indonesia, there are public operators providing nationwide coverage. And then the cost element for you would be the subscription fee that you would need to pay the public operator. And if you are building your own network, then there's a hardware cost of the LoRaWAN gateways. And if it is your network, those gateways needs to be managed by a network server. There's another cost element there. That network server could be running in the cloud, operated by the LNS vendor, or it could be running on site in your data center, or it could be on an appliance. There are even cases for the small-scale deployments. The network server comes embedded inside the LoRaWAN gateway. And there are even products where this embedded LNS can manage more than one LoRaWAN gateway. So small-scale deployments, right? Those are all other different cost factors. What you don't have to pay is the license, right, for using the radio frequency because you're using unlicensed band. And the cost structure, whether it's whether you're getting subscription from a public operator or you're building your own, it is much less than what you would pay a cellular operator if you were going for, say, Narrowband IoT or LTM. So yeah, these are the different cost factors. And obviously, once you deploy the end devices, you may end up having to service them. Well, not for the battery, right? The battery will last for like 5 years, 10 years, depending on the traffic pattern. But for any other reason, if those devices break down, you may have to go to the field and retrieve them and then reinstall them. So you have to take all these operational costs into account as well. All right. All right. Okay. Oil palm, cocoa, coffee, rubber need the mother of all LoRaWAN network covering with a LoRaWAN constellation of satellites the whole equatorial belt. Can the LoRa Alliance get its act together and show leadership to lower deforestation and protect wildlife and yet increase yields? This is definitely an area where we're very, very sensitive. Like I said, LoRaWAN is here to serve planet and people as well. And for that, we are moving towards having our very first roundtable within the LoRa Alliance to discuss how LoRaWAN is used for the benefit of people and planet. We already know a bunch of them already among our members, how they are helping such humanitarian causes. Now, with that roundtable, we will be unearthing other use cases as well. And our plan is to make this a running theme within the LoRa Alliance, not only on the awareness side, but also to see if there are any extensions or any evolution needed on the LoRaWAN technology. We will be discovering those as well through this roundtable, which I'm hoping will turn into a task force. Given that numerous of us are highly motivated to leverage this technology for such great causes, I'm pretty confident that we will be spinning off this LoRaWAN for Planet task force, and this will be an ongoing conversation among the members to accelerate adoption of LoRaWAN in such fields. So if you are personally interested in that, or if your organization is putting out products in that area, please let us know. We would be very happy to loop you in on the ongoing activities. All right, so regarding the pricing of networks, question is, do network providers charge on a per device and on a per transmission or per data bytes? Can you give an illustrative example, potential range of costs? So I cannot really give an example of the costs, so we wouldn't be talking about the prices, how members or non-members are pricing their services or products. Those are totally outside the scope of LoRa Alliance. But when it comes to the charging models, we see LoRaWAN public operators charging on counting devices. Some of them are only charging based on the device count, assuming they would have reasonable amount of traffic. Sometimes they also have a fair use limits to have a ceiling to make sure the end devices do not abuse the network. Obviously, the end devices should be compliant with the regulations, but even within the regulations, they could be transmitting a lot of data. So putting aside the fair use policy, some operators just charge based on number of end devices. And we also see some of the operators charge based on number of frames. I didn't see anyone charging based on the byte counts, but more so on the frame count. And also, there's a very high motivation to keep billing and charging lightweight, because at the end, these servers are pretty cost effective. In order to, I mean, they are pretty on the cheap side or inexpensive side. And to keep them as such, we have to make sure the billing and charging should not itself become a burden and another cost factor. So yes, those are the two models we see. And then there are also, yeah, when charging per device, it's about if the device sends a single frame or like tens of frames a day, if it happens to be transmitting or receiving on a given day, it counts as like plus 1 day of charge. So these are different type of pricing models. But again, the precise pricing, those are definitely something we cannot talk about within the LoRa Alliance. All right. The question is, what about Basic Station? Do you plan to work on it? So Basic Station is the NS to Gateway, one of the NS to Gateway APIs or interfaces or protocols, and it came out of Semtech. So the predecessor of Basic Station was a packet forwarder. It's not standard. It's a Semtech provided API. Later, Semtech issued, published a Basic Station, which again is a proprietary API. Now within the LoRa Alliance, we're working on the standard API to replace any one of those proprietary APIs in the industry. So I wouldn't say we're working on Basic Station, but we're working on what should replace Basic Station and any other proprietary API in the market so that we can have a commercial off-the-shelf gateway working with another commercial off-the-shelf network server in a mix and match environment. All right, we have reached the top of the hour, but I will stay around as long as there are questions and as long as I can keep my voice going. So feel free to stay around. There are more questions, and I'll keep going. Okay, that's interesting as well. Why there is no such standard in LoRaWAN for selecting gateway while sending acknowledgement from network server to the end device? So the downlink, when the network server has a downlink to transmit, the network server makes a decision about through which gateway to push that downlink, right? Thanks to the microdiversity end device, when it transmits the uplink may have been received by multiple gateways. And each gateway receiving a replica of the same uplink would push the uplink to the network server. So the network server knows through which gateways it has received the very last uplink from that end device, such that if it needs to send a downlink following that uplink, it has a pretty good understanding which gateway is the best. So network server does a gateway selection. Now, we don't need a standard for that. It's one of the algorithms that's implemented on the network server. And those algorithms take into account RSSI, SNR, and then some other heuristic to make sure they're not flip-flopping between the gateways unnecessarily. And it's an implementation method. It's very much like the ADR. ADR is also, we provide the MEC commands that feeds into the ADR and that also executes the decision of the ADR, the adaptive data rate algorithm. But otherwise, ADR is an algorithm. It's implementation specific. We leave it to the vendors to build their own and also to improve on it and to use it as a differentiator. We would not really try to build a standard algorithm because no matter what we build on that as an algorithm, they would build something better. And it's not an interoperability matter, really. It's a local decision to be made by the network server. And given that it doesn't require any coordination between the network server and the end device or between the network server and the gateway, it is okay that it is built inside a black box that's built implemented by the vendor. Okay, this question is about the satellites. Any exciting update on satellite-based LoRaWAN connectivity? When will global level coverage available? Which companies are actively pursuing it? Any use case already implemented? So yeah, I have already touched upon a few of those, but let me quickly recap. We have a satellite task force under the TC, and within that, we have a handful of satellite operators, not just operators, but also these are the companies building their own satellites and satellite payloads. So 3 of them have commercial services, EchoStar Mobile with their GEO satellite and Lacuna and Plan S with their LEO satellite. And these are all commercial services. Today, you can sign up for their service. The EchoStar Mobile has 1 satellite facing Europe. So they already provide a commercial pan-European service. They have another satellite facing North America. They are planning to go commercial on that as well. And the two other operators with the LEO, their satellites are spinning around the Earth. Physically, they have the ability to provide coverage, but they also need to have a license from various countries. And I don't have the latest information on which countries they have license for. You better contact them, Plan S and Lacuna, to find out where they're able to serve today. And in the pipeline, we have at least 2 or maybe even 3 other operators that are looking into or already working on adopting LoRaWAN for their satellite as well. So compared to Narrowband IoT, we are ahead of them. Narrowband IoT doesn't have any commercial service, whereas we have 3 operators with commercial service using standard LoRaWAN. And we expect to see the space-based coverage to enhance. And we already have the ability to integrate satellite-based connectivity with the terrestrial networks to provide complementary coverage through our standard roaming. So yes, we have pretty good momentum on that. The satellite networks are the 4th wave shaping up the deployment landscape. The first wave was the public operators, then it got followed by the enterprise private networks. Then the 3rd wave kicked in, the community networks. Then the 4th wave is the satellites. And we're able to, one can build any one of them and one can build a mix. And then all of these types of networks are already integratable. Today, we have roaming between public and public, between public and private, between a private LoRaWAN network and community, so on and so forth. Any one of those operator network types, we see a mix and match of integration through roaming among them. The question is, if gateways are overloaded, it causes more energy consumption from end device side. So it sounds like a statement, or maybe it's a question missing a question mark. So typically, the gateways would not get overloaded for processing because the amount of data pushed by the end devices, it's limited. It's limited by the regulation of the RF bands we're using. So processing wise, they would not be overloaded. What can happen is if there are way too many end devices overloading the radio waves, like traffic colliding, the collisions are increasing, then that could appear like the gateway is overloaded, but actually that would be the end devices interfering with each other. Now we have a safeguard against that within the LoRaWAN design, and that's the adaptive data rate. When the end devices increase in numbers and when the end devices start transmitting a lot more data, that means the consumption is growing, the business is growing, and that becomes the time to add more LoRaWAN gateways to the deployment. So it's just, logical that there will be more funding to add more gateways. And as one puts more LoRaWAN gateways in the field, thanks to the ADR, the network starts detecting that with the densified network with more LoRaWAN gateways, the distance between the end device and the closest gateway starts to shrink. When that distance shrinks, the gateway starts hearing the uplinks with higher power. Then the ADR algorithm on the network server says, aha, so the end devices are now closer to me. Now I can tell the end device to use higher transmission, higher data rate and lower transmission power, meaning that the end device doesn't have to shout anymore and the end device can start speaking faster. And in return, that decreases the interference. So again, as the devices gets densified, the gateways will be densified, the ADR will kick in, will trigger the end devices to use lower transmission power and higher data rate, which will reduce the interference, and the system will dynamically adjust itself to the evolving demand coming from the end devices. So that's why we see networks being deployed today for the most demanding use cases like water meters. The best example of that is Veolia in France, having deployed 3 million water meters. And these water meters are in the most challenging places inside the buildings. And despite that, they have the confidence that the system will scale for several years and decades to come. They are using the public operator Orange for that. And wherever is needed, they have the ability to densify the network. And this is how the network is safeguarded against any kind of overloading and interference, as this question seems to be talking about. Yeah, so the question is how LoRaWAN will be in harsh environments such as harbor near oceans. So yeah, I mean, harbors are really, I wouldn't say they are as bad as the oil refineries, where there's a super dense area with metallic obstacles. And there are LoRaWAN deployments in ports and in harbors as well. So yes, we are seeing rollouts in such harsh environments already. Yeah, all right. How does LoRaWAN compare with millimeter wave or microwave wireless for smart cities, smart buildings? And do you see a hybrid of LoRaWAN and millimeter wave, microwave? So the millimeter wave is part of the 5G new radio, and the use of millimeter wave is usually for higher throughput. That was one of the driving factors for the 5G. But the downside is it has the range of millimeter wave is lower. Also, penetrating through obstacles gets harder. Now, that's why a millimeter wave system is not a substitute for what LoRaWAN can deliver, but certainly the two can work hand in hand. I haven't seen any use cases the two come together. Well, there are some UWB cases, though, for like fine granularity indoor geolocation, UWB gets used, and the sensor relies on LoRaWAN for transmitting its location, a location that gets detected through UWB. So there are, yeah, such multi-radio devices marrying LoRaWAN with another radio like RFID, Bluetooth, UWB, etc. All right, I'm going to be cycling around. So let's see. All right, okay. This one is about airports. Are there any notable or emerging use cases of LoRaWAN that are particularly relevant for airports and their operational infrastructure? For example, terminals, facilities. I'm interested in understanding how LoRaWAN contributes to operational efficiency, safety, or sustainability in these environments. So yes, LoRaWAN is already used in airports. One example is in my hometown, Istanbul. The Istanbul airport have deployed LoRaWAN, I think, 3 years ago. And then another example is the airport, Pittsburgh airport, and one other is, I think, in Rotterdam, and I'm sure there are a few others already deployed out there as well. What they do is they use it for tracking, for safety, like for detecting occupancy in various parts of the airport, motion detection, for indoor air quality, temperature sensing, for tracking carts and buggies, and also for tracking personnel. Also structural tracking, and environmental tracking as well. So yes, we do have such use cases already deployed in the field. Ah, okay. So here's the question. I've come across the use of LoRaWAN for indoor or large area tracking of assets using triangulation across multiple gateways. However, my impression is that LoRaWAN is more commonly used for static applications. What is your perspective on this? In which industries or contexts is LoRaWAN-based asset tracking include? Okay, it seems like broken. The tail of the sentence is broken. So yeah, so LoRaWAN-based tracking, there are cases where the so-called geolocation is used. Geolocation is a very LoRaWAN specific or LoRa specific way of detecting the location of the end device based on time of arrival. So when the end device transmits the uplink, multiple gateways can receive the uplink simultaneously, like almost simultaneously. And by using a nanosecond timestamp on these receiving gateways, a geolocation solver can use this input, like depending on the precise time the uplink was received. The geolocation solver can resolve the location of the end device with a granularity between like 20 meter and 100 meter when the end device uplinks are received by 4 gateways. So it doesn't really provide a granularity like what you get out of GNSS or Wi-Fi fingerprinting or BLE, but it's a very low cost way of getting a low granularity geolocation. On top of that, there are trackers that uses GNSS receivers, Wi-Fi sniffing, and BLE receivers for use for determining indoor and outdoor location using such assistance. And there are even deployments relying on nationwide networks for tracking assets like bicycles, like cars, even pet tracking. And it is true today, more of the applications are static, less are mobile. And one reason behind that is for campus-wide coverage, it's very trivial to build a LoRaWAN network. For nationwide, you have to rely on the presence of a public operator. And we do have nearly 10 countries with nationwide networks, or at least having the major cities fully covered. But we are so many other countries where there's no wide area nationwide coverage. For that, deploying tracking in large scale in those countries are not practical. And that's why there are less mobile use cases today and more static cases. But we will be seeing this changing over time. All right, good. Thank you for sticking around. So I'll continue answering the questions. All right. I want to ask about LoRaWAN, how to secure LoRaWAN from cyber attacks. So with LoRaWAN, we are using a wireless communication media. And the way to secure any wireless link is to use cryptography, which is using cryptography keys for providing endpoint authentication, data origin authentication, replay protection, integrity protection, encryption. So with LoRaWAN, we are using AES 128 crypto suite, meaning we're using 128-bit symmetric keys for providing all the facilities I just enumerated. On top of that, we're able to use a firmware update over the air, which is an insurance for providing software patch on the end devices in case the software needs to be upgraded, whether it's for some adding new features or for patching a security bug at the application layer. And all of that support has been built into LoRaWAN from day one. Unlike some other wireless communication technologies, which didn't have the proper security from the get-go, and they got retrofitted later on. But by the time we started this development back in 2015, there was already a very good understanding of how to secure wireless architectures, and we did have the right expertise, and we still have a very good, strong expertise within the LoRa Alliance to maintain the security of our architecture and also provide guidance to the ecosystem to build secure products. So today, the level of security you get out of LoRaWAN is on par with what you get out of Wi-Fi, 3G, 4G, and 5G as well. Okay, question is, can you talk about device available in the US for housing, sensors for toilets, T-stats? Also, has it been approved for US military bases? So for finding out what LoRaWAN devices are in the market, I would recommend people to check the marketplace under the LoRa Alliance. If you go to LoRa-alliance.org website, one of the top menus is marketplace. Just get into that. You'll be able to browse through the devices made available by our members. And then you will see there are multiple devices there for facility management. All right. How do you see the LoRa Alliance and LoRaWAN entering newer markets, say like smart home? How does LoRaWAN play in that ecosystems? So yeah, like I said, among all these 7 verticals, smart home is the relatively less developed ones. At the moment, smart home market is served by Wi-Fi, Bluetooth, Zigbee, Z-Wave, um, and the long range or having to penetrate through multiple walls have not been so much of an issue for the home. That's why LoRaWAN did not see too much traction. Having said that, there is already some interest to add long range for a small part of the residences, whether they have very thick walls or whether they're like large estates, or they want to connect assets in their yard or in their basements. LoRaWAN is going to be playing an important role. And also building community networks, meaning you put up a LoRaWAN gateway, so does your neighbors, and now your assets like your pets that happen to want to be like wandering the neighborhood, right? They can stay connected through community networks, and that's where the long range and easy integration of LoRaWAN comes into the picture. So nowadays, the CSA, the alliance that builds Matter, have been looking into adding a long range communication technology, and we are looking into proposing LoRaWAN to CSA, and it's a work in progress. So there's a good chance that we will be proposing that, and if it goes through, seeing LoRaWAN as part of CSA would be one way we would be accelerating this market adoption. Are there any upcoming large-scale deployments or success stories the Alliance is championing to showcase LoRaWAN's real-world value? There are always success stories coming up. I mean, we do run into them. We cannot even keep track of them at the moment. So we just discover them through conversations. We go to a trade show, we see people talking about them, and so among them there are new nationwide networks being added. The most recent one being DRE, which is a subsidiary of 3 Hutchison from Hong Kong. They have deployed in Austria, and in terms of large scale water metering, I can give the example of Yorkshire water metering in UK, 1.2 million water meters. This is the size of the project, which is starting now. And so yeah, a few others I've talked about, like the Starbucks, like the Verizon deployment in Atlanta arena. And in LoRa Alliance website, there are use cases that you can dive in and see several concrete use cases that we've been promoting through that channel. So we're always promoting them. Also on LinkedIn, if you are not, please do follow LoRa Alliance on LinkedIn, and then you'll get to see the success stories we are promoting. And also our next big event is in Barcelona. We have evolved our event strategy. Now, starting with this year, the large LoRa Alliance events will be embedded inside other trade shows. The next one being the IoT Solutions World Congress in Barcelona in the middle of month May. And that's where we're going to be having a 19-member company LoRa Alliance Pavilion and a one full day track of LoRaWAN conference. Both in that conference and also at the member booths, you will see we will be talking about several success stories. And there'll also be numerous demos that you can see LoRaWAN live in action. So I would highly recommend people in this meeting and those who are watching on demand later to check out the event. If possible, come and meet us. We would be very glad to tell you about the latest and greatest success stories during the event. And you'll also find that event very insightful. You will see people talking about the technology and the deployments, and you will hear things that you would not be able to see on LinkedIn or being shared on mailing lists. The face-to-face conversations are always super helpful in discovering things that usually go that doesn't get written anywhere else. Let's see. What is the significance of LoRaWAN certification? So as I have touched upon at the onset, we subject the LoRaWAN end device to a very rigorous testing. Now, this testing is done using a tool that we have developed called LCTT, LoRaWAN Certification Test Tool. We make this test tool freely available to our members, and they can subject their end device to this test tool to run the tests on their own. And upon passing all these tests, they can either submit their end device, the test results to the LoRa Alliance for certification, or they can also resort to using an authorized test lab. We have several authorized test labs who are an expert in running these tests. So they can run those tests on your behalf and provide you guidance where they fail. Plus, they can also run an RF testing for your end devices, which is another added value of the ATLs. And through either way, whether you run the test on your own or you go through the ATLs, then the test results are submitted to the LoRa Alliance, and then we provide you the LoRaWAN certified logo, which you can use with your device. We also give a preferential marketing to your end device in our marketplace and in our marketing activities. And there are several customers already demanding the LoRaWAN devices be certified, especially the utilities and any serious deployment that is seeking quality assurance of the end devices. They are asking for LoRaWAN certification. And in order to get certification, you need to become a member. We have three different tiers of membership. We have adapter level membership. Actually, it has two tiers within itself. There's a startup adapter. If your annual revenue is less than $1 million US, then you can qualify for becoming a startup level adapter member. It is the annual fee is $3,000. If you don't qualify for your revenue being under 1 million US dollars, then adapter level membership costs you $6,000 a year. And then the contributor level member, where you get more benefits, including sitting at the committees and steering the work, also getting higher access to marketing activities, and also getting the so-called net ID. Net ID is the network identifier, which is used for generating your own dedicated device, globally unique device address space. So if you apply for a contributor level member, you get a larger device address space, and then there's a sponsor level membership, which makes you eligible for applying for a board seat, and you get a much larger device address space, and you have a voting right in selecting the board members and committee chairs as well. So you are basically at the steering level, giving influencing the direction of our activities. So, okay, I talked about the membership. Now, falling back, that's the value of certification, and that's what it takes to get your devices certified. Oh, all right. Okay. Is LoRaWAN Alliance, is LoRa Alliance a partner of any educational institutions? So we have another tier of membership called institutional members. These are open to universities and government agencies, nonprofit organizations, and they are eligible to become a member free of charge. Now, so even though they can become a member free of charge for the renewal at the end of the first year and any other year, we expect them to deliver a task that would be a contribution, like say writing a white paper, like presenting LoRaWAN at an international conference, or adding an educational curriculum to their program, things like that. We have a pool of such tasks that the institutional members can pick up from. And these are also great opportunities for the institutional members to collaborate with the LoRa Alliance members, the industry players. So if you are from a university, I would highly recommend you check out that program. And you can apply, I think, somewhere on the Zoom tool, we have provided a link to the membership. So if you go to LoRa-Alliance.org/membership, you can see information about all these different tiers and what it takes to apply to become a LoRa Alliance member. Let's see. Oh, right. That's a good question too. It very well resonates with what we are working on. What are the key strategies the LoRa Alliance is pursuing to accelerate large-scale adoption of LoRaWAN technology, especially in sectors and geographies where uptake has been relatively slow? So we have our first decade behind us. So LoRa Alliance is 10 years old. And within that 10 years, we have reached a level where we have more than 100 million LoRaWAN devices deployed in the field, spanning all 7 verticals. We have members and deployments all the way from Alaska down to New Zealand. Having said that, this is just the beginning. The runway for LoRaWAN is much, much, much bigger than what we have achieved. And now we are seeing exponential growth. Our largest member networks, like the one provided by Zener, which has more than 9 million connected devices, and Actility more than 4. The Things industry is nearly 3 million devices. They are seeing 50%, 50% CAGR annual growth on their device counts. But that's not enough. That we can bend the curve further upward to accelerate that. And for that, what we've been focusing as I took over the CEO role, one of the things we are focusing on is awareness and education. While we have been very busy, heads down, building the technology, and our members have been building their products, we have reached a good level of maturity. We've been a little too busy with that, and the marketing side and the awareness and the education side has been a little bit neglected. So now we're focusing on that to bring LoRaWAN to many other places. And this AMA is part of that. We have town hall. We're going to a whole lot more events now and taking up a lot of opportunities. And in addition to that, another strategy we've been executing is reaching out to other ecosystems, IoT ecosystems, and collaborating with them to integrate two ecosystems and two systems together. For example, for metering the DLMS, we have a liaison with the DLMS UA. Through that, we defined how one can carry DLMS over LoRaWAN. So any DLMS-based deployment, without having to touch the rest of the system, can easily slide in LoRaWAN to replace their legacy wireless communication system. Same thing we have done with the OMS, another metering standard. OMS over LoRaWAN is part of our standards, and we have a associate liaison as well. And more recently, we are doing the same thing with BACnet. We have initiatives in bringing BACnet integration with LoRaWAN. Luckily, we don't need to do any standardization on that. It's mostly a marketing activity and a liaison activity. For example, 3 weeks ago, we had a chance to send representation from LoRa Alliance to the Niagara Forum event in the UK, and that was the beginning of the Niagara ecosystem adopting LoRaWAN, or accelerating the adoption of LoRaWAN to their BACnet-based smart building system. So we will be doing more of that, and for that, actually, we do rely on the input from the ecosystem. If you see a large ecosystem that we can get in touch with, we can set up official liaisons or joint working groups. We are all psyched about bringing the benefits of LoRaWAN to existing IoT ecosystems. So that's part of our plan to accelerate the acceleration of LoRaWAN adoption in the market. All right. We seem to have a good participation. Okay, so the question is, can we use LoRa without a LoRaWAN network, peer-to-peer? What are the limitations in such a mode? So some of the proprietary stacks over LoRa are for peer-to-peer use, but those are built by some vendors in some corner of the world, and certainly we don't stand behind them. And they being proprietary, one cannot achieve interoperability with them. Also, the quality you will have to check because they are typically built by one company at a time, as opposed to built by world-class experts that we have within the LoRa Alliance in the technical committee. Now, having said that, you could be asking, when will LoRaWAN have a device-to-device communication? So we did already publish a technical recommendation on that. It's called D2D LoRaWAN using multicast management. Now, it is a technical recommendation because there are parts of that recommendation that are underspecified. For that, building a fully interoperable device-to-device communication would require some proprietary extensions. So that was a good exercise, but it doesn't really bring a full peer-to-peer or device-to-device communication. Now we have some internal conversation around if and when and how can we build a LoRaWAN based device-to-device communication, fully interoperable for support for commercial off-the-shelf devices. It's an ongoing conversation. The work hasn't officially started yet. We'll see if and when we do that. But there's conversation around that. So stay tuned. If you are part of the LoRa Alliance, we can discuss that within the TC, the technical committee. Otherwise, please stay tuned for our future announcements. Could you discuss your thoughts on terrestrial satellite LoRaWAN providers? Is it really just cost that is stopping the advancement of satellite, or are there other factors? Do you see a lot of mergers in the future between terrestrial and satellite? So like I said, there are already 3 commercial providers, LoRaWAN connectivity through satellites, and there are at least a couple more work in progress. I would say that's already pretty good momentum considering deploying a gateway in space is not as simple as deploying one terrestrially. And also the market segment and the size for space satellite-based connectivity is much smaller than what's happening on the ground. So due to these factors, it's not surprising to see the number of players in space is less than the ones operating on the ground. And regarding mergers in the future between terrestrial and satellite, that's definitely a possibility. I don't see that happening these days yet. It's kind of too early for that, in my humble opinion. But certainly in the future, we will see. Well, first we'll see collaboration among them, and then potentially mergers could happen in the future as well. But that's a commercial matter, which we don't have much say in it as LoRa Alliance. That was just my personal opinion, by the way. Are there any protocol level enhancements or best practices the LoRa Alliance is exploring to mitigate packet loss due to duty cycle restrictions and aloha nature of LoRaWAN, particularly in high density or mission critical deployments? So we already have several features to deal with that, like the ADR is one, using multiple channels is another one, using application layer redundancy, forward error correction is another feature we have. Macro diversity, which is built in, also plays into this. And gateway densification through low-cost picocells, low-cost relays, and low-cost walk-by, drive-by reading. These are all the tools we have in our toolbox. And for the extreme case of density, that's where we see with the LEO satellites and also the geo satellite. A typical LEO satellite has a so-called spotlight. That's the coverage it provides. A spotlight of a diameter more than 3,000 kilometers. So within which the number of devices that would fall under is pretty high numbers, right? Thousands and thousands and even millions of devices. In order to serve so many devices, these satellites are using LRFHSS. Long range frequency upping spread spectrum modulation, which is another modulation supported by LoRaWAN. And it is that modulation that provides extreme support for extremely dense networks, but which is only needed for the satellite networks, not for the terrestrial. So we not only have a lot of advanced features deployed on the ground, but also we have more in our pipeline as well. And beyond that, We also added the collision detection mechanism. That's a recent addition to the LoRaWAN standard as well. So before transmitting the end devices, they can listen and see if there's anyone else using the channel with a LoRaWAN transmission. And upon detecting that, the end device holds itself back. The CSMA support. So we also brought that in the recent years. So yes, we are very well prepared for further densification. So you can safely use LoRaWAN, and that's what super large networks have been doing. And these are the kind of networks where they deploy their devices like the water meters and gas meters. These devices would be in place for more than 10 years. And these utilities and the networks providing connectivity to such utilities also provide SLA, service level agreements, with penalties, meaning that providing connectivity, even in the extreme cases, is part of the contracts these network operators have with the utilities. So yes, we're pretty well positioned to have the IoT deployments scale well for several decades. Okay. In a dense LoRaWAN deployment, what's the best case scenario for scheduled or expected packet loss, and how does the LoRa Alliance define acceptable thresholds for reliability in such environments? It's really very application specific. We don't really dictate any metrics in that. It depends on your application. Say if you deploy a bunch of temperature sensors in a building, it might be okay that they're losing packets like once in a while, because eventually you can reconstruct the temperature pattern. Whereas if you are, say, detecting a vibration anomaly, or if you're detecting, say, temperature in a oil refinery, then definitely you would have much less tolerance for packet loss. So it's really up to the application to decide how much tolerance is acceptable. Given LoRaWAN's long range but low power nature, how effective is it in basement or -0 level deployments where RF penetration is challenging, and are there specific strategies or hardware optimizations being explored in such scenarios? So with the high sensitivity we have, reaching -142 dBm, penetrating through multiple walls is already possible. There are even deployments with sensors under the ground, like one of the parks in Sydney. They have sensors 10 centimeters below the surface of the soil to detect the moisture, and they have been working pretty well. And in order to boost this effort, definitely antenna design is key. Having a dense network is key, and you can further densify your network using relay nodes as well. So these are typical measures in the market. Is LoRaWAN in action going live in the next month? I think you're referring to our meeting at the IoT Solutions World Congress in Barcelona. Yes, it is next month. So I think the link is already shared among the members, so you can see the details there. So again, the question is about the use cases among the global deployments so far. Which LoRaWAN use case do you consider the most impactful or transformative in terms of scale, efficiency, and return on investment? Could you share where it's been implemented most effectively? So, I mean, I did give some examples already. This is a really subjective question, right? I mean, what impacts your life more might be different than what impacts anyone else's life. But overall, where we have the most momentum, the best uptake, the metering in water metering, gas metering, smart buildings, street lighting, campus-wide tracking, smart construction, smart mining, smart industries, connecting sensors at the manufacturing sites. These are the areas that we see pretty good momentum. And with the smart buildings, we are already at the pole position, the leading wireless communication technology being adopted. And smart water metering, we have a pretty good position as well. The others are accelerating significantly. Okay, I think I'll go on a little bit more. Um, okay. Currently, LoRaWAN has native support for GPS time synchronization, but it appears to lack native support for pushing time zone to nodes. Are there any plans to introduce time zone synchronization in the LoRaWAN stack? Yes, we do have GPS time synchronization. We do that through Class B beacons. The Class B beacons let the end devices synchronize with the GPS without having a GPS GNSS receiver. Now, the time zone, yeah, we don't have that. We are not really planning to do that. We would leave something like that to the application stacks right now. So the application stack can take care of it on its own way. Whether it rises to the level that we see the need for standardizing that, yeah, that's an interesting input. Yeah, I'll take this to the TC and let's see what others think. If there's enough common voice behind this, it could become a work item. Okay, the question is, does the new interface between gateway and LNS include possibility of load balancing downlinks between gateways covering the same nodes? So, like I said before, the gateway selection is a network server choice, okay? So it is the network server implementation that makes the decision about which gateway to select for transmitting the downlink. So it doesn't really involve any interoperable interface, right? It's the network server's decision. It says, hey, gateway 1, you send this downlink. Hey, gateway 2, you send this other downlink frame. You don't need a standard API. You don't need a standard protocol to assist this. Because network server already knows what it needs to know. It knows where it has been getting the traffic. It knows what's the load level of the gateways. And as such, it can pick and choose which gateway through which to push the downlink. So yeah, it's just an implementation matter. You need to discuss this with your network server vendor. Okay, which is dependent on which, LoRa and LoRaWAN. So I think the question is, what's the relationship between LoRa and LoRaWAN? So LoRaWAN is the link layer, LoRa is the physical layer. LoRa is in the physical layer. It's a modulation technique used at the physical layer. Another modulation technique is FSK, and LRFHSS is yet another one. And LoRaWAN is able to use any one of these. So in the OSI stack diagram, at the bottom is LoRa, FSK, LRFHSS. Right above that is LoRaWAN as the layer 2, the link layer. Right above that is the applications. So we have only 3 layers in our stack, which is very efficient. We don't have like full 7 or full 4 layers that TCP/IP stack has. It's only 3 layers. With the increasing demand for multi-protocol solutions, how is the Alliance promoting interoperability between LoRaWAN and other IoT standards like Narrowband IoT or BLE? Actually, it would not be called interoperability. It is more like integration of LoRaWAN with the other technologies. And at some advanced point in time, it could be interworking. For example, there is something called interworking between Wi-Fi and say LTE, right? And with the interworking, what they mean is there's a core network which can serve both LTE radio network and Wi-Fi radio network, and the traffic can all be aggregated in single core. Today, this is already possible with LoRaWAN, but it's up to the vendors to build platforms that can serve both LoRaWAN radio networks and Narrowband IoT radio networks. And there are such vendor platforms out there. Now, we are also seeing the radio integration on the end devices like the trackers integrating BLE transceiver, Wi-Fi transceiver, and GNSS transceiver with LoRaWAN transceiver. LoRaWAN being used for the internet connectivity, whereas GNSS, BLE, and Wi-Fi being used for geolocation purposes, for indoor and outdoor geolocation purposes. And we also recently published a spec that was a byproduct of our liaison with the GS1 Alliance, where we defined how to carry GS1 identifiers like RFID identifiers over LoRaWAN. So yes, we do see multiple radios collaborating in different forms and shapes, and there'll be more of that moving forward. All right, we are almost reaching the end. A couple more minutes and then a couple more questions. Yeah, okay. This question is like looking at the next 3 to 5 years in the LPWAN landscape. How does LoRa Alliance strategically view the role of non-terrestrial networks NTN in expanding LoRaWAN's addressable market and differentiating it from competing technologies? What initiatives are underway to ensure the LoRaWAN standard evolves to fully leverage the potential of satellite connectivity for large-scale global deployments? So we have the satellite task force under the TC, which is specifically working on further improving the integration of satellite networks with the terrestrial networks, and also having commercial off-the-shelf end devices already interoperate with the satellite networks. So nowadays we're working on standardizing different channel plans for the satellites, also standardizing the ephemeris and the beacon format. So any end device can work with any satellite networks. So it's integral part of our strategy. We have recently had a webinar. You can watch it on demand by going to LoRa Alliance website. Under the webinars, you can find the on-demand video. That's where we have these 3 members talking about the technology and their products and the commercial services. With that, we have reached the end of the hour. I think this is the second hour. So, well, I would like to thank you all for joining this first AMA session. You had very great questions. I have answered as many as I could fit under the 2 hours. I think there are a few remaining ones. We'll have more such sessions in the future. Please do check out our website, LoRa-Alliance.org. You will see a lot of materials under the resource library, webinars, videos, and white papers and success stories. And if you are not a member of the LoRa Alliance, I would highly recommend you join. Several benefits, including steering the technology, tapping into our experts. We have the best LoRaWAN, obviously, experts and the best IoT experts. By being part of the Alliance, our expertise becomes a natural extension to your R&D. And you can get your end devices certified, and you can build your ecosystem by making new friends among the LoRa Alliance members. And join the marketing committee. We boost your marketing activities through having you exhibit with us, go to events, organize webinars, list your company in our member directory, list your products in our marketplace, get you on stage with several events where we source speaking opportunities. So yes, we have numerous benefits. Check out our membership information at lora-alliance.org/membership. And yes, we're looking forward to hearing from you again. Thank you all for joining. So let's adjourn this very first AMA session. Have a great day now.